Guys, let's solve the problem valid parenthesis. So essentially we are given a string s and we have to see whether the parentheses are valid, and they are valid if you think it looks valid, meaning that an open parenthesis needs to be closed with a closed parenthesis, and an open bracket needs to be closed with a closed bracket, and a curly brace needs to be closed with a curly brace. So they need to be in order, meaning if there was something like this, let's say if it was this would not be a valid solution because the closed square bracket is coming after the open parenthesis. So this would not be a valid solution. So what would be a valid solution if this was coming here, in which case the parenthesis is closing, the closed parenthesis is closing the open one, and I meant this. And the square bracket, open square bracket is being closed by the closed square bracket. So how do we solve this question? Essentially, we have to have a linear pass through the entire string, but what we have to do is if we find something that's open, we can use a data structure called a stack. So if you find something open, we add it to the stack, and we keep doing that. But when we find something that's closed, so if we find something that's closed, we can have a map, and we can map all the closed brackets, meaning the parenthesis, the square bracket, and the curly brace. We can have the corresponding open entity in that map. So when we find a closed bracket, we can refer to the open side, and what we can see is on that stack, what was the last element. So the last element would be the last open bracket that was added, and basically the closed brackets pair should match the open entity, meaning if this was mapped to this, then as soon as we find this, we should see that the last entity on the stack was this. And if that is the case, we can continue moving forward. We'll pop it off, of course, and we can continue moving forward. If it's not a match, then it's a fault. It's an error. Then that would mean that basically we had, for example, a opening parenthesis here, but we had a closing bracket, let's say here, then the corresponding value should have been this, but in fact we see on the top of the stack it was this, so it would be an error. So I think it's easy. Let's just code it up. So first we have to have a stack, which is the data structure we are using to reference the last character on the string. So we have to add it to the stack, and then we define a map. So we'll say this is a close to open map, and let me type it out. So this is our map, parenthesis with the parenthesis, bracket with the bracket, and curly brace with the curly brace. So close to open, right? And then we'll say for each character in the string s, because that's what we are going through. So there are two conditions. If C is in close to open map. What does that mean? That means that C is one of the closed brackets. So if we encounter a closed bracket, then do something. So let's say just type pass, whatever needs to be done. And else, what is else? Else means that it is not in this map, which means that it has to be an open bracket. So so if it's an open bracket, then what do? We say stack dot append and whatever that C is. So now let's just fill this up. So if this is in fact a closed bracket, then what do? We'll have to see whether this whether the topmost entity, meaning the last character on the string, which we can get using stack -1. This is the last character. So if this is equal to close to open map, and here we'll say of C. So what are we doing? So in case we encountered this, so using in case we encountered this, the closed entity. So we'll do a reference on the map and we'll see what is the open entity corresponding to this closed entity. We'll see this. So we'll see if the top value on the stack, which is the last character in the string, if these two are equal, then what does that mean? That means that everything looks fine. Open matches closed. So we'll do a pop, because now that this bracket pair has been validated, we don't need to validate it anymore. So we pop it, and then we'll continue on moving forward. But if that is not the case, then that means that the top element of the stack did not match this. Then we know that it was an error because the pairs did not match. So here we can say return false. So this looks good. This means that we go through the entire string, and in the end, what do? We not only should everything match up, at the end of the day, we should not have any open parenthesis left, because if there was an extra closed parenthesis which did not match an open parenthesis, we would definitely get a false. But what could happen is we could have some open parenthesis left in the stack without a corresponding closed parenthesis. So to check on that, what we'll say is return a true if not stack, meaning the length of the stack is 0. This is what it will do. Else false, meaning if there's something that's left on the stack, then this not stack would be, so then stack itself would be true, so not stack would be false. So we'll give a false if there's something left on the stack. All right, this looks fine. Let's give it a run. It looks accepted. Okay, it says index out of range, stack of -1, close to open map. All right, what we have to do, yeah. So before we check something like this, because we are checking whether there's a value, what's the last value, we also have to make sure that the stack itself uh, is filled up, because if there's no stack. So for example, if we were checking on the first value, and let's say we found the first value, let's say, was a closed parenthesis. So we were checking whether the top value on the stack is equal to the corresponding uh, value here, but we cannot check that because there was nothing in the stack to begin with. So before we reference the stack, we have to make sure that the stack itself is available. So in the first instance, it would not be available, so this condition would not allow it to check it further. So I think this should do it, and it gets accepted. All right, guys, see you in the next one.